All right, in this lesson, in lesson 10.5, we're going to be looking at trigonometry and area. This lesson is very similar to 10.3, where we're looking at area of regular polygons. These polygons are going to be ones that will not be able to be used by a 30, 60, 90 right triangle or 45, 45, 90. These are the ones where we'll have to use our sine, cosine, and tangent to find either missing apothem, side length, or perimeter. And then we're also going to look at finding the area of triangles using trig. So you can use trigonometry to find the area of a regular polygon when you're given one of the following: length of a side, the radius, or the apothem. So you're going to be given one of these three in our lesson today: the side length, the radius, or the apothem. You may be even given the perimeter. If they're giving you the perimeter, you can divide it by the number of sides to find your side length, and that'll help you find your apothem. So it all depends on what you're given is how you attack the problem. So let's take a look here. Get right into the problem. What is the area of a regular nonagon with 10 centimeter sides? Round to the nearest square centimeter. So in this case right here, we're going to round to the nearest whole number. So the first thing we need to do is we're going to draw part of our figure. Now we're not going to draw the entire nonagon. So what I'm going to ask you to do is just draw the center. Then let's take and draw our right triangle. So we'll take, for the first part here, I'm going to draw the triangle like we had it yesterday. So one of our triangles that are in our nonagon. Now I'm going to draw the apothem as well. All right, we have a right angle here. Now, then we're going to write down our six steps. Nespacha: number of sides, side length, perimeter, central angle, half angle, and apothem. So in this case, we have a nonagon, which is 9 sides. The side length is 10 centimeters, which means this whole side right here is 10 centimeters. So we've got to find the half side length, which would be 5. Now, the perimeter would be 9 times 10, which is going to give us 90. We don't have the apothem, so we need to use our central angle and half angle. So we're going to start by taking 360 divided by the number of sides, which is 9. And that's going to give us 40 degrees. Our half angle will be 40 divided by 2, and that's going to give us 20. Which means that this angle up here, our half angle, would be 20 degrees. This is our apothem. Now, we know that this is 10, so it means this length is 5 because this apothem cuts this triangle in half. Now once again, this is not the entire nonagon, this is just the one triangle from it. And that's all we're going to focus on is the one triangle. So we've got to figure out how can we find our apothem when we're given a side length and an angle measure. So we go back to our trig functions. We don't have 2 sides, so we can't use Pythagorean theorem. It's not a 30, 60, 90, so we can't use our special right triangles. So we're going to use one of our trig functions, sine, cosine, or tangent. Now, this is our reference angle of 20. 5 is the side across from it. And A, what we're looking for, is the adjacent leg, which means we're going to be using tangent. So tangent of 20 degrees is equal to the opposite, which is 5, over the adjacent, which is A. Now, we'll just set up our proportion here and cross multiply. A times tangent 20 is equal to 1 times 5. Once again, we're solving for A, so we're going to divide by our tangent function of 20. And so A is equal to 5 divided by tangent 20. Now, we could write this over here as our apothem as 5 over tangent 20. But you can also calculate this value, and we're going to round off to 4 decimal places. So let's do that now. So in our calculator, we'll do 5 divided by tangent 20. Once again, make sure you're in degree mode. That gives us 13.7374. So 13.7374. So that is the decimal approximate to 5 divided by tangent 20. So we're going to use this instead of having to write this into our equation. So once again, we have 1/2 the perimeter, which is going to be 90, times the apothem, which is 13.7374. Now, since we still have this number in our calculator, the full decimal here, so we're going to use the exact value here and just say times 90 times 1/2, which is the same thing as 0.5. Calculate that value, and the area is equal to 618.18, which means when we round to the nearest square centimeter, it's going to be the whole number, so this will be 618. So the area is equal to 618 square centimeters. So, find our reference angle to find our apothem using our tangent function. Remember to round to 4 decimal places. That helps us, so when we round our final answer, we have enough significant digits to make sure we get the right result. All right, so let's go to the next one. Part B, what is the area of the regular pentagon with the 4-inch side? Round your answers to the nearest square inch. So pause the video now, attempt this one, and come back and check your work. All right, so let's see what we did. We got our picture drawn, similar to the last one. We've got the number of sides is 5, side length is 4, gives us a perimeter of 20. Central angle, because we don't have our apothem, we use our central angle to get central angle of 72. Take half of it, which is 36. So 36 becomes our reference angle. So in order to find our apothem, once again, we're going to use tangent because we have the opposite and adjacent legs of the right triangle. Tangent 36 is equal to 2 over a. Now we're going to divide by the tangent of 36, which cancels out on the left, leaving us with a equals 2 divided by tangent 36. Now this decimal equivalent is approximately 2.7528. So as we calculate this value in our equation, we get 1/2 of 20 times 2.7528, and we're going to get approximately 28 square inches. Remember, we're rounding to the nearest square inch. All right, so let's move on to another one. So this one, we were given a side length. Let's look what happens when we're given a radius. A stop sign is a regular octagon. The standard size has a 16.2-inch radius. What is the area of the stop sign to the nearest square inch? So, in this case, we're going to mark our center here. You can use this, you can draw it on a separate sheet, separate area, but I'm going to draw my apothem, going straight down. And then I'm going to set up this one side of my right triangle here. So they give us the radius this time, which is 16.2 inches. So we'll start writing down NS, P, C, H, and A. Now, number of sides we know is 8. We don't have the side length, so therefore we can't find the perimeter. We don't know the apothem, so we first start off with the central angle. So 360 divided by 8. That's going to give us 45. Then we take the 45 and we divide it by 2, which is going to give us 22.5. This means that our reference angle right in here is 22.5 degrees. So we have two things to find. Anytime you have a radius, you got to find both the side length and the apothem. So the apothem is here, but the side length goes from here all the way to here. And we don't have a trig function that's going to give us the entire side length. So what we're going to do is we're going to mark this as x. This segment from here, this is half our side length. Now, what I want you to recognize is to find s, you're going to have to take your side length and you're going to multiply it by 2. So the side length is going to be 2 times x because this side over here is also x from here to here. So let's look to see what trig function we're going to have to use to find our not only our apothem, but our side length. So let's start with the side first. To find the side length, we are looking at, we have the hypotenuse, which means it's either going to be our sine or our cosine for both of them. Now, the x is the side across from the 22.5, which means we're going to be using the sine, which is opposite over hypotenuse. So we're going to take the sine of 22.5 equal to the opposite, which is x, over the hypotenuse, which is 16.2. So once again, we cross multiply. 1 times x is x. This becomes 16.2 times the sine of 22.5. Now, once again, this is not our side length. This is just part of it. So now I'm going to multiply this whole thing by 2 because I want 2x. So that means that's going to equal our side length now. So our side length is going to be twice this. So what you can do is you're going to take and multiply 16.2, and we're going to multiply it by 2, which gives us 32.4. So we're only doubling the outside number. We don't have to multiply this 2 through here. So it's going to be 32.4 times the sine of 22.5. So that's my side length. So I'll come over here and I'll write my side length as 32.4 sine 22.5. Now we're not going to calculate this decimal just yet because we want to stay and use exact figures or exact numbers as long as possible. So just like we multiplied this by 2, the x by 2, we're now going to take and find our perimeter by multiplying 8 times the 32.4. So we've got this number in our calculator. We're going to say times 8, and our perimeter is going to be 259.2. So 259.2, and bring down the sine of 22.5. Now at this point, you can calculate that decimal equivalent. So we'll go back to our calculator. 259.2 times the sine of 22.5. That's going to give us the number 99.1915. So we'll write 99.19, and that was 15. So that is our decimal equivalent that we'll use for the perimeter. Because remember, we need to find the perimeter, and now we need to find the apothem. So to find the apothem now, we're going to start at our reference angle again. We know we have the hypotenuse, and we have the adjacent leg, which means we're going to use cosine. So we'll write down the cosine here. The cosine of 22.5 is equal to the opposite, or the adjacent, which is a, over hypotenuse, which is 16.2. And we cross multiply. A times 1 is a, and then 16.2 times the cosine of 22.5. So now we'll just write the decimal equivalent here. Okay, and that means we'll take 16.2 cosine 22.5. That gives us 14.9668. So we write 14.9668. So that will be our apothem. We'll write up here 14.9668. And now we calculate the area. Area is equal to 1/2 times our perimeter, which is 99.1915. And our apothem is 14.9668. So now we'll go back to our calculator. We've already got the apothem in here, so we'll just say times 99.1915. And then we're going to multiply it by 0.5 to get the half. That gives us 742.29, and it says round to the nearest square inch again. That means the whole number, so we're going to look to the 2. The 2 does not round this 2 up at all, so it becomes 742 square inches. So the area, 742 square inches. So that's how we find the apothem or side length when we're given a radius in a regular polygon. So if they give us the side length, and we're looking for the apothem, we're going to be using the tangent function. If they give us the radius and we have to find the apothem and side length, we're going to use the sine function for the side length and the cosine function for our apothem. All right, so let's move on to the next one. The tabletop has in the shape of a regular decagon with a radius of 9.5 inches. What is the area of the tabletop to the nearest square inch? So set this problem up, work it out, and come back and check your answer. All right, so we set our equation up, we draw our triangle. We have our side length is 10, or we have number of sides is 10. That's all we have. So we had to start with our central angle and found that 360 divided by 10 is 36. Our half angle is 36 divided by 2 is 18, so that's our reference angle. X is the half the side length, A is the apothem, we have the radius of 9.5. So we're going to use the sine function, sine of 18, to find our half of our side length. This is x over 9.5, which becomes x equals 9.5 sine of 18. We double it to find our side length of 19 sine 18. So that is our side length. Multiply that by 10. So 10 times 19 is 190 sine of 18, which gives us 58.7132. Now, to go find our apothem, we're going to use the cosine function because we have the adjacent over hypotenuse. So cosine of 18 is equal to a over 9.5. Cross multiply, a is equal to 9.5 cosine 18. And that approximate is going to be 9.0350. And our last step is to plug everything in, multiply it by a half, and then round to the nearest square inch, which is going to give us approximately 265 square inches. All right, so this is going to be the first part of the video here. The second part will have the area, which is the last part of our lesson, the area of a triangle using trig, and then part 3 is going to be the practice problems. So pause the video now.